Imagine a universe teeming with life, yet we've never encountered any form of alien civilization. Welcome to the Fermi paradox. This paradox presents an intriguing contradiction that has puzzled scientists and thinkers for decades. It's named after the Italian-American physicist Enrico Fermi, who famously asked, "Where is everybody?" during a casual discussion about the possibility of intelligent life beyond Earth. This question reflects the heart of the paradox. Given the vastness of the universe with its 2 trillion galaxies, each potentially hosting billions of stars and their orbiting planets, it would seem logical to assume that the cosmos should be teeming with life. Statistically speaking, we should have encountered plenty of extraterrestrial civilizations by now, but the reality is we haven't. We've seen no signs, heard no signals, and made no contact. This puzzling silence from the universe led to the formulation of the Fermi paradox. If there are indeed countless potential homes for life out there, why haven't we found any evidence of their inhabitants? Is it because life is incredibly rare and we are indeed unique? Or is it because intelligent life tends to self-destruct, leaving no trace behind? Perhaps the conditions needed for life as we know it are far more specific and complex than we assume. Or could it be that we are not looking in the right way or at the right places? Maybe we're not even asking the right questions. In the quest to solve this paradox, we've come up with numerous hypotheses, ranging from the Great Filter Theory to the Rare Earth hypothesis, and even the simulation hypothesis. Each of these theories presents a unique perspective, shedding light on various aspects of this cosmic conundrum. So, if there are a multitude of potential civilizations out there, the question remains, where is everybody? To understand the paradox, we must first grasp the enormity of the universe. Imagine a cosmic expanse so vast it's beyond human comprehension. Picture billions upon billions of stars, each potentially hosting a system of planets. The sheer scale of the cosmos, with its endless galaxies, each filled with countless stars and planets, is truly mind-boggling. Now, let's think about the possibility of life beyond Earth. Among the multitude of stars, there exist an astronomical number of planets that could theoretically be just right for life, much like our own blue-green gem, Earth. These are the planets that reside within what scientists call the habitable zone. The Goldilocks region that's not too hot, not too cold, but just right for life, as we know it to exist. This brings us to a fascinating tool used by scientists to estimate the number of advanced civilizations in our galaxy, the Drake equation. Named after astrophysicist Frank Drake, this equation doesn't give us a definitive number, but rather it provides us with a framework to explore the numerous factors that would be necessary for communicative extraterrestrial life to exist. It takes into account elements like the rate of star formation, the fraction of those stars that have planetary systems, the number of planets that could potentially support life, and several more. The Drake equation, in all its speculative glory, suggests that even with the most conservative estimates, there should be a significant number of civilizations out there. But here's where the paradox comes into play. Given the age and vastness of the universe and the predicted number of extraterrestrial civilizations, it begs the question, why haven't we detected any signs of them? With such astronomical numbers, it seems almost impossible that we are alone. Yet, here we are, seemingly the only voices echoing in the cosmic arena. The stage is set, the players are in position, but the expected cosmic symphony remains eerily silent. The question then is not merely where is everybody, but why is it so quiet out there? Could there be a cosmic roadblock preventing civilizations from contacting us? Enter the Great Filter. This concept, proposed as a solution to the Fermi paradox, suggests that there's a formidable barrier in the evolutionary timeline. This barrier, or filter, is so challenging to overcome that it prevents life from developing to a point where it can communicate across the cosmos. Now, you might be thinking, what could this filter possibly be? Well, there are several proposed filters, each as daunting as the next. One such filter could be the emergence of life itself. The process that transforms simple organic molecules into a complex, self-replicating organism might be so unlikely that it rarely, if ever, occurs. Another proposed filter is the leap from simple, single-celled organisms to complex, multicellular life forms. On Earth, it took almost 3 billion years for this transition to occur. That's twice as long as it took for multicellular life to evolve into intelligent beings capable of contemplating the cosmos. So, it's possible that this step is a significant hurdle for life elsewhere. Then there's the development of intelligent life, and more importantly, A civilization that can communicate across interstellar distances. Perhaps the journey from primordial soup to smartphones is a road less traveled in the universe. But here's the catch. If these filters are behind us, it implies that we're among the lucky few who've made it past these cosmic hurdles. However, if the great filter is yet to come, it could mean a grim future awaits us. This might involve global catastrophes like nuclear war or ecological collapse that could end our civilization before we have a chance to make our cosmic debut. So is the great filter an answer to Fermi's question, where is everybody, or is it just another piece of the cosmic puzzle we're yet to solve? If the great filter is ahead of us, it poses a grim future for humanity. If it's behind us, it could explain the silence. Could it be that the universe is silent by choice? This question brings us to the silent universe hypothesis. This intriguing idea suggests that alien civilizations might be intentionally avoiding communication. But why would they do that? Well, consider this. Imagine a dense forest teeming with diverse creatures. Some are harmless, some are beneficial, and some are predators. If you're a small creature in this forest, do you announce your presence to all, or do you stay quiet, listen, and observe? The universe could be akin to this forest, and we, along with other civilizations, are the small creatures, choosing silence over exposure. This hypothesis proposes that advanced civilizations might consciously decide to remain silent to avoid drawing attention to themselves. They could be observing, listening, and learning just like the small creature in the forest, choosing not to reveal their location or existence. This could be due to various reasons: fear of hostile civilizations, avoiding disruption of their society, or simply a collective decision to observe and learn before making contact. Let's also consider the concept of a dark forest in the universe, a term borrowed from Liu Cixin's science fiction novel, The Dark Forest. In this scenario, all civilizations behave like hunters in a dark forest, staying quiet and cautious because they understand the potential risk of revealing their location. The universe, in this view, is a dark place where silence is the best strategy for survival. This could explain why we haven't detected any signs of extraterrestrial life. It's not because they don't exist, but because they choose not to communicate, at least not in ways we can currently detect. The silent universe hypothesis is chilling yet fascinating, stirring our imagination and curiosity. However, it also raises an important question: how do we as a civilization act in this vast cosmic forest? Do we shout out our existence, or do we too choose the path of silence? It's a chilling thought, civilizations choosing silence over discovery, but it's a thought that might just hold the key to understanding why the universe seems so eerily quiet. Space, the final frontier, but can we ever conquer these vast distances? This question has been at the heart of humanity's quest for understanding our place in the cosmos. Interstellar travel, the journey between the stars, presents a multitude of challenges that science and technology are yet to overcome. Firstly, let's consider the sheer enormity of the distances involved. Our closest star, Proxima Centauri, is a staggering 4.2 light-years away. That's roughly 25 trillion miles or 40 trillion kilometers. Even if we could travel at the speed of light, a feat currently beyond our reach, it would take us more than 4 years to get there. Secondly, the energy requirements for such a journey are colossal. Traditional rocket propulsion systems simply won't cut it. They are too slow and inefficient for interstellar distances. Even the most advanced propulsion technology we currently have, ion propulsion, would take tens of thousands of years to reach even the nearest stars. Thirdly, time dilation becomes a significant factor at relativistic speeds. As you approach the speed of light, time slows down for the traveler relative to the stationary observer. This means that a trip to a nearby star could take decades or centuries in Earth time, even if it feels much shorter for the voyager. Moreover, there's the issue of survival in the harsh conditions of space. Cosmic radiation, microgravity, and the psychological effects of prolonged isolation are all serious concerns for long-duration space travel. And let's not forget the need for sustainable life support systems and a source of food and water for such a long journey. Despite these challenges, humanity's spirit of exploration and discovery continues to push the boundaries of what's possible. Advances in technology, such as the concept of warp drives or the use of wormholes, might one day make interstellar travel a reality. But as of now, even at the speed of light, we're centuries away from our nearest neighbors. In the midst of this cosmic silence, one organization listens: SETI. The search for extraterrestrial intelligence is a collective term for the scientific search for intelligent extraterrestrial life. For example, monitoring electromagnetic radiation for signs of transmissions from civilizations on other worlds. SETI's work is vast and complex, much like the universe they're exploring. They use large radio and optical telescopes to scan the sky, hoping to pick up signals that cannot be produced by natural celestial bodies. These signals, if found, could be the proof we need that we're not alone in the universe. But it's not as easy as simply tuning into a radio station. The universe is a noisy place. Our own planet produces a lot of radio waves, and there are numerous natural cosmic radio sources as well. Deciphering a potential alien signal from this cacophony is a Herculean task. And then there's the issue of where to look. The universe is unimaginably vast. Our Milky Way galaxy alone contains hundreds of billions of stars, each potentially hosting planetary systems, and beyond our galaxy there are countless others. So, where do you even begin to look in this vast cosmic ocean? SETI scientists have devised strategies to narrow down the search. They focus on stars similar to our Sun, which are likely to have planets in the habitable zone. They also target specific types of radio frequencies, which they believe are most likely to be used by advanced civilizations. But despite these strategies and decades of searching, SETI has yet to find a definitive signal from an extraterrestrial civilization. This doesn't mean the search is futile, it simply underscores the vastness of the task and the patience required. In this grand quest, SETI stands as a beacon of human curiosity and determination. They continue to listen, to search, undeterred by the silence. As we tune into the cosmos, we can't help but wonder, is anyone tuning into us? What if everything around us, including the universe itself, is nothing more than a simulation? Imagine an advanced civilization far beyond our own technological capabilities, having the power to simulate entire universes, complete with galaxies, stars, planets, and even life. This is the essence of the simulation hypothesis, a concept that has been gaining traction in both scientific and philosophical circles. The hypothesis suggests that we, along with everything we perceive, are part of a sophisticated simulation, much like a hyper-realistic video game. The creators of this simulation could be an advanced post-human civilization, or perhaps a separate external entity entirely. But how does this tie into the Fermi paradox, the seeming contradiction between the high probability of extraterrestrial life and the lack of contact with such civilizations? Well, if we are living in a simulation, it could be that the creators have simply not programmed extraterrestrial life into our particular version of the game. Perhaps we're in a simulation designed specifically to study the development of a single, isolated civilization. Or it could be that our creators have indeed included other civilizations, but have set the parameters so that we are not yet capable of making contact. Furthermore, the simulation hypothesis could also explain why we haven't detected any signs of alien life. If the simulation is designed well enough, its creators could easily manipulate the data we receive, effectively hiding any evidence of extraterrestrial life. Of course, these are all speculations. The simulation hypothesis, while intriguing, remains unproven. It's a concept that pushes the boundaries of our understanding, challenging our assumptions about reality itself. But isn't that the beauty of exploring the unknown? It forces us to confront our limitations, to question our perceptions, and to continually seek out the truth, no matter how strange it may seem. If we are indeed in a simulation, it could explain the absence of contact with extraterrestrial civilizations. But until we can prove it one way or another, the search continues. And who knows, the answers we seek may be stranger than we could ever imagine. As we continue our cosmic journey, the question remains, are we alone? The future of our search for extraterrestrial life is more exciting than ever. As our technologies advance, so do our methods of exploration. We're not just looking for planets anymore, we're looking for signs of life, for techno-signatures, for anything that might suggest we're not the only ones in this vast universe. Consider this: the life we're searching for might not be as we expect it. It could be microbial, existing beneath the icy surfaces of moons, or perhaps even intelligent, far beyond our own comprehension. It could be communicating in ways we can't yet understand or perceive. The possibilities are endless and the universe is vast. We must keep searching, keep listening, keep exploring. Our understanding of life is based on a sample size of one: Earth. But the cosmos may have different plans. The search continues, and perhaps one day, the cosmic silence will be broken.